So, welcome everyone. This is session 6 of our morning agenda here in W1, W2 in Rot. Very happy to see so many faces because we have an amazing talk by two of our HANA Cloud product experts. So here with us are Jonathan and Shraddha, and to not waste any of their time, I'm handing over directly to them. So this is your stage.
All right. Thank you very much. Glad to see not everybody has left for lunch yet. Very nice. Okay, so we're, like the talk says, we're going to give you a little bit of more database-centric tips and tricks, what you can do when working with CAP. I'm going to specifically talk about application deployments, how to optimize and get around some scenarios where the deployment might not work in an optimal way out of the box. And later, Shraddha will tell you a little bit more in depth about how you can deal with custom table migrations. All right, already wasted a minute. So let's get started. So here you can see Business Application Studio, and I have a simple CAP application, which is basically the sample application, but that'll do for the scenario that I've planned. Now, I'm going to use the SAP HANA projects view to deploy it because I'm concentrating on the database part. But you can do essentially the same with running CDS deploy to HANA. All right. Now let's start a deployment. See what happens. All right, now this starts the deployment. This looks the same in when you deploy a CAP application, and what you can already see is it's now sitting here and writing files, and apparently something's taking long here. And what's taking long here is the reason is I have here a big file of book data which has almost 500 megabytes. Which might not be completely realistic, but in actual projects you have you could have many files, especially CSV files tend to get big, and so it sits a lot in this writing part where it writes the files to the database and then tries to figure out what actually needs to be deployed, because by default it does this check on the database side. But as you have seen, this can prolong the deployment times if you have lots of big files that need to be sent to the database. And for this, there's actually a parameter that can be set in the HDI deploy options, which is called optimize file upload. And what this does is essentially, it does the check what needs to be deployed, not on the server side, but on the client side. And in the case of very large files, this can really speed up the deployment because it doesn't have to transfer everything to the database side, but it just gets the hashes of the deployed file to the client side. And then it does the calculation there. Of course, the drawback is now it needs a little bit more resources on the client side, but let's just give it a try. So the initial deployment took about almost 19 seconds. And now with this parameter, what happens? Right, starts another deployment. And right here it is now in the synchronizing file state. And as you can see, now the deployment time came down from like 18 to 5 seconds. Because it didn't have to transfer this file. Of course, if the file had actually changed, it would still need to transfer it. But as long as it doesn't change, this can give you a huge speed up. All right, so far so good. Now let's take a look at the data model that I have. And so let's start with the basic one. It has the books table. And what it did add is a books details table, which, as you can see, has a large string data type. So it can hold lots of data. And of course it does in my case. So what happens if I try to change this table? Let's say I want to add an abstract, just some string, doesn't matter, right? And now I deploy it. Now what'll happen is CAP will generate HDI files, and then the deployment is started in the HANA database. And as you can see here, now this table, HDI tries to get it into the new format that I had specified. And because this table has lots of data, and by default, HDI is not really smart with detecting changes to tables. And so it just resorts to copying the table, recreating the table in the new format, and then transferring all the data. And as you can see, this can take a while, especially with tables that have large amounts of data. With small tables, there's not much difference, but in this case, it can take a while. And Shraddha will later talk about options to get around this. One is to use hdbmigrationtable as a format where you can specify exactly how the tables should be migrated. And what I'll use here is a relatively new feature. There's also a parameter where HDI can be a little more intelligent for certain types of changes, how it does that. For example, adding a column, removing a column, changing a column type. That's all changes that HDI can now detect and then not copy the whole table, but really do that change selectively. And so this table is called try-fast table migration. It's called try-fast table migration because, like I said, it only can do it for certain types of changes. And if it can't detect the change, it'll still resort to copying via shadow table. All right, but let's try it. OK, now the deployment was successful. So even though it took a while, now I have this new abstract column on the database. So say I realized I didn't actually want to have it here. I'm just going to remove it again. And if I hit deploy now, it would still copy the table in with the old way, and it would still take 94 seconds. But since I have now set this try-fast table migration parameter, let's see what happens. I'll try another one. So synchronizing the files again on the client side. Otherwise, this would take a long time. And here you can see it's already done, right? It took 8 seconds. And if you look at the deployment log, you can actually see, right, that it did run it in the fast migration mode, which right now, so it didn't copy the whole table. It basically just said alter table, drop column. And this is, of course, much faster than copying everything. All right, so this is a very useful parameter that can really speed up deployments in certain scenarios that are supported by the try-fast table migration. OK, I'm going to show one more thing. So if you have cross-access to different schemas, you typically set up a list of synonyms. And in my data model, I have now defined here proxy objects for some tables that are in some other schema. And I have created a bunch of views on top. So I can access these other tables and views in my CAP application. And I also have a list of synonyms, right, for these tables. And let's say I have another synonym here that's totally unrelated. But now I make a change here and deploy it again. Right. What you can see in, what you cannot see in the deployment log because I haven't actually changed it. So what you can see here in the deployment log, although I have only changed the definition of synonym 4, it's still redeploying all the tab 1, tab 2, tab 4, right? And so if you bundle your synonyms into this one file and then do a deployment, a lot of things can redeploy it unnecessarily. Because by default, HDI works on the file level, and I have technically changed that file. Not everything, but the file, and so it redeploys everything. And there's also a parameter to change that behavior. This is actually called skip unchanged expansions. Expansion is a term, right? So from these different synonyms from this one file, individual synonyms are expanded. And so if I do a change now, let's say change it back to 1. And redo the deployment, then HDI will internally figure out what all synonyms are coming to this file and do an individual check on each of those and only redeploy what has actually changed. Right? And as you can see here, only things that are really related to the synonym 4 are now redeployed. And if you have, huge object hierarchies based on one synonym file, which if you bundle everything in a synonym file, then the whole project could be dependent on that. And this can also really save you deployment times, right? Because only a very small subset has to be redeployed instead of everything. All right, and with that, I will hand over to Shraddha to have some time for her.
Okay, perfect. Yeah, so Jonathan showed you how you can do it with the HDI deploy parameters. So here also I have a simple cup project with some entities defined. Oh, okay. Yeah, perfect. Totally missed that part. Okay. Okay, let me start again. I have a simple cup project here, which basically has like 3 entities, country, person, and company. And these 3 entities, how it will be generated for the HDI, I will show you in a while. So basically, I have used 2 annotations here, that is the CDS persistence journal and CDS persistence exist. Basically, this is used to, the CDS persistence journal is used for the HDI migration table. So now once I go ahead and do the build of the, give me a second. It would generate the table, the HDB table and the HDB migration table. So we can find that in the gen folder in our project explorer. So the HDB table would be the parameters, the columns with which we defined in the entity, and the HDB migration table would consist of the first version of what we did the build with. And if I want to go ahead and modify this particular entity and have the definition done in the HDB migration table, I would go ahead and change in the CDS persistent general that entity, and I will add another column, for example, person eye color and description. So here also to mention, I've added, I've defined a type called description and identifier, which basically is like the 2 variation of the string with the 2 different lengths. And I have tried to keep it in a consistent way in the data model here. So now I have added another column, and I want to change, I want to delete the person name here as well, and just maybe keep the person last name here. And now if I do the CDS build, I would get an error also saying that the manual resolution is required. So that means that I have to manually edit the HDB migration table. So if we go into the HDB migration table for the person, it would show me the 2 versions here. The one is the version that was earlier shown, and the other one is where the alter capabilities is explained, and also like the dropping of the person name here. So because we are dropping that particular column, so it is in the comment format, and also comments are written about, the drop statement can cause lose the data loss, and hence, yeah, do you really want to do that? And in the case of adding another column, you can see that it is not in the commented version. It is saying like add person eye color with, nvarchar 150. So now I want to still go ahead and do that because I don't have any data in it. This is just for the demo purpose. And also, maybe have a look whether you really want to drop that particular column, and then you can go ahead and delete the comments here, and then we will proceed with the CDS build again. Or you can just go ahead and CDS deploy. So now I don't see any error. Now I will go ahead and deploy this particular project. This would take a couple of seconds. And I will go ahead and open my database explorer from the CUP application. Taking a couple of seconds. I have a lot of HTIs here. And now if I go into the tables, I would see the two entities that I defined, HDB, the country and the person. Now, as we have seen earlier, that there was another entity that was defined here, that is the entity company, but it was not shown in the Database Explorer because I have already created the HDB migration table here. But I have ended that file with .txt. So let me rename this and deploy this again. And this HDB migration table basically consists of the columns, that is company ID, name, location. So what happens right now is now I want to change the company location string length from 250 to 200. So currently, if I go to my Database Explorer and Database Explorer and refresh it, I would see the recap company with the string length of 250. Now I want to reduce it to 200. So what I would do here is I have another migration table .text file here, which basically does the update of the company location string from 250 to 200. So here I'm renaming the column location to another column and then dropping the older one. So what I will do here is I will rename, this is a lazy man's approach, by the way. I'm renaming this to v1.text. That's the version 1, which I originally had, which had 250 as the character length. And now I will rename it to the normal HDB. And now I will go ahead and deploy this. This should show now when you refresh your Database Explorer and see the character length of the company location, you should have 200 as the length, string length. Yeah, as you can see here. So this is the different variations of how you can make use of HDB migration table. You can make use of the alter capabilities, and also you can make use of the update capabilities. So yeah, that's all from my side. And I think I consumed more time. I'll hand this over to Jonathan again, and we are open for questions.
That's all right. I mean, I can fill another 20 minutes, but I think we'll stop here.
Yeah.
So if there's some more questions, then feel free to ask, I guess. Yeah.
So what I've used in my scenario is like I use the left function, which I mean, like if it is like an extended length, then it would that would return the number of the length from the data. But yeah, that's what I've done in my scenario from reducing from 250 to 200. From the left, yeah.
But it's up to you to do it, right?
Yeah.
So HANA will not do it. So if you do it without the left and there's something longer than the 200, you'll get an error.
Okay, so I have to keep the time. I'm sorry for the questions in the room, but Jonathan and Shraddha will be around so you can ask them. Let me just quickly finish this off officially. You can talk about any questions later. So this is the morning session, everybody. Thank you so much for your time. If you haven't had lunch, you can do that till 2 p.m. And we will continue with the afternoon session in this room at 1:30. So it was my pleasure to host you this morning. The afternoon will be Anna Maria. See you soon, everybody.